Right. So we were discussing about the friction, and we have applied the equations of equilibrium using frictional resistance. We have discussed few numerical. Now we will discuss few more, and let us try to make our concepts even clearer. So let's take up this one example. Uh, there is a ladder, and this ladder is resting on one vertical face and another horizontal surface in this manner. Okay. Uh, it is of 24-meter length, and it weighs 40 Newton. The weight of this ladder is 40 Newton. It is placed against a vertical wall at an angle of 60 degree. So this inclination is mentioned as 60 degree. How far along the ladder? How far along the ladder can 160 Newton man climb before the ladder is on the verge of slipping? I will repeat. How far along this ladder can a 160 Newton man climb before the ladder is on the verge of slipping? Angle of friction at all contact surface is given as 15 degree. So now, instead of coefficient of friction, angle of friction, static friction is given. Why I am saying this to be static friction? Because in the numerical it is said, what it is saying that how far a 160 Newton man can climb in order to make this ladder just slip. Okay. So first of all, let me know what should be the direction of slipping. I mean, in which direction this ladder may slip by the virtue of that load or that man's weight. In which direction do you anticipate the ladder to be moving? Yes, yes, come again. Right. Right direction, correct. And since this is going to move in the right direction, what do you think this point to be moving? It will move in the downward direction. Am I right? Correct. So let me call this point to be point A and this to be point B. So we have understood the behavior of this ladder. I mean, as far as the motion is concerned, we know in which direction this ladder is going to move or it is going to just slip. That's why we have introduced this static term, because we know that this is not in ultimate motion. It has just started its motion. Okay, just it has impended. Now, once we know the complete situation, now what we can say, we can introduce the self weight. Self weight will be acting exactly at the center of this ladder. What it is given, it is 40 Newton. And now we are supposed to identify the position of that 160 Newton man or person uh, with the with, let's say, point A or point B. Okay, that we are supposed to identify. So let me consider the position of this man, which will allow this ladder AB to move in its right direction or slipping direction. Let me consider the man to be standing at this location. Let's say at a distance of x. X थोड़ा confusing है, so what I can say A. ठीक है? At a distance of small a from point B. This is what I will assume. And this is 160 Newton weight. Based on this, I can certainly draw the free body diagram. So for free body diagram, even if I draw this sketch, that is more than sufficient. Sketch in the sense single line diagram. So how many reactions do you expect at point A? Two reactions. Very good. One will be horizontal, another will be vertical force. Now this force won't be reaction force, this is frictional resistance. So which direction do you expect the frictional resistance at point A? Excellent. Why? Because point A is moving in the downward direction. Resistance offered shall be in the upward direction. So let me call this to be FA. Let me call this as normal reaction at A. Am I right? Normal reaction at this thing. Secondly, we have already identified this position of 160 Newton per cent, and this is the self weight, which is of 40 Newton. Next, over here at point B, similarly, you will find normal reaction at B and resistance. I will draw it like this. Is this okay? Yes, sir. Okay. So let me call this as F suffix B. Correct? Let this be position or the distance of that person from point B to the small a. Okay, and this is B. Right? Total length of ladder AB is given as 24 meter, and therefore this distance from A to this will be 12 meter. Correct? This will be 12 meter. ठीक है. Right. Next, angle of friction. This is mentioned. From this information, what can you calculate from this information? Coefficient. Coefficient. What is the relation between this? Tan of phi. Tan of phi s is given as, sorry, tan of phi s will be equal to tan of 15 degree. How much does this come out to be? 0.27. 0.27. This is your mu s. Correct? So once you have calculated the mu s value, then it becomes very simple for you people to identify the rest of the values. For example, FA. Now FA over here shall be how much? 0.027 times NA. Similarly, FB shall be 0.027 times NB. Now it is a matter of geometry and the calculation part. Okay? So what you do? Apply equations of equilibrium. Summation of force in x direction equal to 0. How many forces do you observe over here? NA. Then minus 0.27 times NB equal to 0. Is it okay? Yes. Summation of forces in y direction equal to 0. So 0.27 times NA, this is positive, minus 160 minus 40 plus NB equal to 0. This equation 1, equation 2. Now, these two equations are not sufficient enough, I suppose. Or can we find out the values of NA and NB from these two? I think. Yes, sir. So please find out NA and NB. Yes. What are the values?
Sir, NB equals to 186.39.
Acha, 186.4, let's say. And what about NA? Is it
50.3.
हाँ
Yes, sir, 50.3.
50.3, okay, 50.3 ठीक है. So once you have calculated these values, our aim is to identify this A. So what you do, you take moment, and you can choose any of the points, either point A or point B, to consider the moment. So let's say moment about point B equal to 0. Okay? Since we are considering the location of this 160 Newton from point B itself, so you can take that moment about the same point B. So what are the values? NA into perpendicular distance. What will be the perpendicular distance? Please calculate the perpendicular distance. Hello. Hello. Good morning. Actually, finance officer. जी. हाँ हाँ वो मिल गया था वो मेंटर सर और मैं आएंगे एंड उसके ऊपर क्या है ठीक है जी हाँ रिपीटेड तो जो नहीं है उसका बैंक डिटेल्स पे वेरीफाई करें. Fine. Yes, sorry. So, how much it should be? 24?
Cos 60.
Cos 60. This will be perpendicular distance if I am not wrong. This vertical distance. So, will it be sin 60? This will be sin 60, correct. And on the similar line, this. Now, this is going to rotate in clockwise direction, so this is positive. Similarly, if I consider this component, 0.27 times NA, this is again going to rotate about point B in the clockwise direction, only the perpendicular distance shall be this much. So, plus 0.27 NA into, now over here it will be 24 cos 60 component. Barabar hai? Next is 160 Newton. This is going to rotate in the anti-clockwise direction about point B. So initial step itself, I am saying 1 minus 160 into perpendicular distance now shall be how much? Will it be A cos 60?
Yes, sir, A cos 60.
A cos 60. What I will do is, this being unknown term, A cos 60. Okay. Next, 40 Newton. Again, it is going to move, rotate in the anti-clockwise direction about this point B. Over here, this is 12 meter. So this will be 12 cos component, 12 cos of 60 degree. Am I right? And
Yes, sir.
equate it to 0. You have already calculated NA value over here. Substitute that value and find out A.
So 5.6.
5.6. Sure. Any other value, please let me know. Because I am getting 12, around 12 point some value. Please verify. Yes, I am getting this value to be as 12. Okay, you can solve it.
So 12.16.
12.16. Okay. Since we have rounded that mu value from 0.267 to 2.27, that's why the difference is there. Otherwise, the value is exact 12 meter. If you consider 0.267, so the value comes out to be 12 meter. So there is no problem as such. Then, yes. Now, a uniform plank, PLANK, plank of weight capital W and the total length 2 times capital L is placed as shown in figure. So there is a wooden plank. That wooden plank is placed on these surfaces, you can say. These are inclined surfaces. This is 60-degree inclination with horizontal, and there is second surface whose inclination with respect to horizontal is 45-degree. These are rough surfaces. This wooden plank is actually placed in this manner. Okay. Now what is given? The weight. Weight of this wooden plank is given to be capital W. And length is total length. Let's say this is point A and point B. So AB length is 2 times L. That means this will be L and this will be L. What you are supposed to find? The angle of friction is given to be 15 degree, 15. You are supposed to determine the maximum value of the angle at which slipping impends. Let let us call this angle to be alpha. Okay. Okay. And now just let us try to analyze this thing. By the virtue of this weight, what is the natural tendency of the plank to move in which direction? Do you feel that this plank will move with the help of this weight. Yes. Let us speak in terms of these points A and B. So by the virtue of yes, yes.
Downward to this.
Uh, you mean to say what will be the direction of point A? In which direction the point
Upward.
A? It will move in the upward direction. And what about point B?
Downward direction.
Downward direction. So fine. Based on this, you have understood that by the virtue of this weight, this is going to move in this manner. That is, point A will try to move in the upward direction, and this is a slipping tendency. Okay. So with the help of that, we are now supposed to draw the free body diagram. In the sense, what you will do is, this is the normal reaction at point A and normal reaction at point B, and A and B. Correct? Since this is going to move in the upward direction, frictional resistance shall be downward. And since this moves in the downward direction, this will be upward. Again, the phi s value is given. It is 15 degree. Mu s shall be tan of phi s. This time let us take it as 0.267. So this value will be 0.267 times MB and 0.267 times NA. 268 instead of 7, 268. Okay. Right. Fine. So let this angle be alpha, and we are supposed to identify this angle at which the slipping impacts. Okay. So let us draw the sketch, single line sketch, representing all the external forces available. So this is W. This is point A. From here to here it will be L. Here to here again it is L. Okay. Now this angle, rather this reaction and this frictional resistance. Okay. And over here, this will be like this, 45-degree inclination, and this is somewhat like this. Right. So this is NA and B. This value is 0.268 NA. This is 0.268 NB. Fine. This is alpha value. Let us draw this reference line you can consider, so things may become clear for calculation purpose. So now over here we can decide the axis. So let us consider this axis system itself, XY, and with respect to this we will resolve the inclined forces. Okay. So over here all these things are inclined, Na, Nb, and this also. So you resolve this. Can you please let me know what will be this angle?
60 degree.
ठीक है. This will be
30 degree.
correct. Similarly, यहाँ पे तो कोई problem नहीं है. Everything is 45. So the resolution, if you can see, I have drawn in this manner. I suppose that this is okay. ठीक है. So this is 30 degree, 60 degree, like that. Right? Now, summation of force in x direction equal to 0. I will write down the values, you please verify. 0.268 times Na cos of 60 minus, rather plus this Na cos 30 minus Nb cos 45, doesn't matter, cos sign doesn't matter, or in order to avoid confusion I will write this as sin 45, sin 45, then 1 minute, ये 45 है ना, तो ये 45 रहेगा, तो cos, ठीक, it will hardly matter, then plus 0.268 times Nb cos 45, anything else equal to 0. So please verify this equation. Is this okay? Ultimately, I will get this value Na minus 0.517 times Nb. This is what I am getting. You please verify. Similarly, summation of forces in y direction equal to 0. You will find positive is Na sin 30 minus 0.268 times Na sin 60 minus W. This is one of the force plus Nb sin 45 plus 0.268 Nb sin 45 equal to 0. 45 degree equal to 0. Right? But now over here the problem is I need to find out this alpha value, isn't it? So that alpha value should be incorporated in our equation. Okay? So first of all, what I will do is I will bring this equation in terms of W. So I am getting this to be W equal to 0.268 times Na plus 0.896 times Nb. Okay. So this is equation 1, let's say, this is equation 2. Okay. So by solving these two equations, what I will get is, now I will get Na and Nb in terms of this W value. Okay. For you people, I will solve it, or rather, I will write down the Na and Nb values. You can verify them. Nb, I am getting it to be 0.966 times W. This is one thing. Second thing, Na, I am getting it to be 0.5 times W. What we are doing actually, we are calculating alpha. All these things we are doing in order to calculate alpha value. This is the simplification, Na and Nb. Now, based on these two values, I am in a position to calculate alpha. And how to calculate alpha? For calculation of alpha, I will have to take moment about any of the points. So you take moment about, let's say, point B, again point B. Okay. So, okay, you can solve these two equations in order to find Na and Nb. You will get these two values. Okay. I will rub this part. And now let us try to evaluate alpha. So let us take moment about point B. Summation of moment about point B equal to 0. Okay. So we need to be careful. Now everything will be in terms of alpha value, alpha parameter. Okay. So now let me consider this horizontal component 0.268 Na. What will be the multiplying factor? Will it be 2L sin alpha? Do you agree? Okay.
Yes, sir.
Then it is going to rotate in the clockwise direction. Similarly, this component, this is going to rotate in the anti-clockwise direction. So straight away minus sign 0.268 times Na into this perpendicular distance. So how much it shall be? 2L times 2L cos alpha. Next is this normal reaction. So normal reaction, this component, if I consider, this is going to rotate in the clockwise direction about point B, and therefore this is plus. I have continued over here. Na, what is this component? Sine 30 into perpendicular distance shall be 2L cos of alpha. Similarly, this will rotate in the clockwise direction. Na cos of 30 into 2L, in this case sine alpha, right? Then there is W. W will rotate about point B in the anti-clockwise direction. So minus W into, what will be the value over here? L cos of alpha. Am I right? Because I'm considering this to be the perpendicular distance. So this is L cos of alpha equated to 0. You substitute Na and Nb in this equation itself, and you will get the value of W. Rather alpha. Because everything will be in terms of W. You will get the equation in terms of sin alpha cos alpha, and then you will be in a position to equate sin and cos alpha value, and from that you will get the tan alpha term. And then you take the tan inverse value, you will get value of alpha, and I am getting that value of alpha to be 36.2 degree. You can verify this. Substitute Na and Nb in this equation 3, and then you will get alpha value. Okay? So you can try this. We will discuss few more numerical uh, in the next class. And we will find that uh, friction chapter can be extended to one more concept, which is known as the wedging action. That I will be discussing after your test 1. Test 1 syllabus, you all know that it is up to equilibrium portion. Friction will not be asked, and it will consist of the syllabus which we have discussed right from the beginning, the day 1 of the lecture. Okay? I have already posted all the content, all the videos, video lectures also. Even though if you have any query, you can ask me whenever you find any difficulty. Okay. And as far as assignment is concerned, you are supposed to submit it by today itself. Today is 28th, no? Okay. Is this clear, all of you?
Yes, sir. Yes, sir.
So I will stop over here. Thank you. You people can leave. You people can leave.
Thank you.
Yes.
पेपर में पूरे न्यूमेरिकल से रहेगा ना?
There might be some theory, जैसे कुछ definitions, axiom, engineering mechanics principles, those may be asked. ठीक. Thank you.
Thank you, sir.